Hello, can you hear us? Yes, fine, thank you. Good afternoon, everyone. So I hope the digestion is not kicking off too much. I think it's a lot of talk. So again, I'm Bruno Annick. I'm from BorgWarner. We are one of the major automotive supplier in the industry. I'm glad to be here with you and to introduce Mathieu da Graça, who's been working with us for 10 years, I would say, and working on gasoline and working now on hydrogen combustion, which is a really different alternatives to what we've seen so far in propulsion solution. It's simple, it's fast to go to the market, and it's cost effective. So we've been collecting a lot of questions, and we want to answer to all of them in this presentation. Yeah. So Mathieu, yeah.
So here first I would like to present you what we are doing at BorgWarner. So we are here in the H2 summit, so everybody is used to use fuel cell in the way to use it with O2 to produce electricity. In our company, we're working on combustion engines since decades, and we thought that would be a good idea to use the hydrogen not to produce electricity, but directly to use it to make combustions and to make some thermal energy and the conversion on the chain. So the idea like this is to reuse all the product line we know since decades, like the injection system, the electronic control units, and the regulation pressure. And unlike the normal combustions, where it's creating CO2, which is really the problem for the global thermal change, it will only produce water. So that's our idea behind it. So how does it work, basically? If you take the normal utility van, you will have a diesel engine, so what we call the compression combustion engine. And what we will put in place with our injection system, it's something very similar to a gasoline engine. That's what we call a spark-ignited engine. It's also the same, basically, at what you will find on all CNG system. So it's very small adaptation on the engine itself. It's not the new technology. It's more to transform the technology we have mastered and that we have optimized since a lot of time.
And the big question is, how do you adapt the system into normal vehicles? Is it very easy to transpose into vans, for example?
So for all the OEMs, in fact, when they had to adapt to the new change for battery electric vehicles and for fuel cell vehicles, it's a total change for the vehicle architecture. On one side here, you have the diesel engines, where you found the nominal equipment. So you have vehicle actuators and sensors. You have the pedals, the fan. You have an engine, which is a diesel engine at the beginning. You have then the diesel control unit, a diesel tank, and you have something very important for thermal engine. We have emission norms, so you have an after treatment system. When we converted this to the H2 system, we had to change the engine, so it's small adaptations from the block. You still have a normal block, you have pistons, you have rods. It's purely mechanical. You have a specific control unit which is dedicated to the H2 system, because now you have to deal with new actuators like the injector, like the spark plug. You have also all the safety on board to take, because you have hydrogen tanks, you have valves, regulators, you have H2 sensors for the safety, for the leakage, etc. And you have to replace the tank from the diesel by a H2 storage system. And our idea is that as the OEM has already a good basis for all the vehicle platform, we are focused on providing a complete architecture for the control unit around the hydrogen. And inside this control architecture, the idea is really to have the control unit of the engine and all the safety on board, which is very important, because everybody is fearing that the hydrogen is dangerous, but as long as you master it as a system, it's very safe.
So Mathieu, how does that compare to other technologies? This one looks simple. What's left?
So I think here everybody's convinced that the fuel cell has very strong benefit against the battery electric vehicle in terms of the power storage density, about also the time for refilling and the simplicity of the system. Compared to the fuel cell system, the main advantage we see is you don't need to break your vehicle architecture. It's really small adaptation. You still have an engine bay. You need always to find rooms to put the tank, but it's really simpler to integrate this in existing baselines because you have many, many machines and it's always complex to reinvent all the structure from the powertrain. Another one which is very important, if you take a utility van, normally you would expect this to be like 120 horsepower minimum, up to 200 horsepower. And to put 200 horsepower of the fuel cell, it's going to be quite expensive. And it's always a problem for the high power variant of the small vehicles. So that's where we know that an internal combustion engine is pretty good at.
But tell me something, I mean, this is based on combustion engine, and I know that everybody is still under the stigma of combustion. Yeah. Is it really a big issue, combustion? Does that create CO2?
So that's the good questions about, that's the one we had on the booth by everybody. If you're burning H2, do you do CO2 in the exhaust lines? Basically, the emissions of a utility van, it's 230 grams per kilometer. So that's pretty big. At the air inlet, you are aspirating the air, and here you have more than 400 ppm, 500 ppm inside the room. So there is CO2 flowing through the engine. So at the exhaust, for sure, you will measure some CO2. This will be around 5 grams per kilometer. The oil you're burning from the piston rings, from the lubrications of the system, it's very small. It's lower than 1 gram. The after-treatment system as well is making very, very few amount of CO2. Actually, it's so small that we spend more than few months to assess this level of measurements. Because today in the industry, nobody is measuring the level which is that low. Something to think as well is that we came to the conclusion that if you measure what the driver is emitting just sitting in the car, or when you are bicycling, you are actively doing some CO2 grams per kilometer. So the pure zero, it doesn't exist in the reality. But what we achieve now, it's basically so low that it's almost impossible to measure accurately.
So maybe we should stop cycling. That would be a start, no? Shall we?
Maybe.
But maybe let's see first, maybe how is it mature, this technology today for us?
So the H2-ICE technology, it's pretty recent. So at BorgWarner, we started like 2 years ago when we had the growing demand from the customer to deliver not just injector, but also a complete system, including the software and the handling of the H2 system. Little by little, we went to build a concept for the engine, and we had also to win the experience to build the first prototype of the car. So the first van started a bit more than 1 year ago, and step by step, we went through the assessment of the feasibility of the engine, the controllability of the basic task, because when you are in a car, you want it to start, you want it to be able to drive, to have an idle, to have stop-start, to have all those things. Once this was assessed, we worked on the emission certifications, on the robustness of the system, on the safety. And today, we have a quite mature system that is actually demonstrated on the parking. That's the red van that you see on the picture. And we are in a phase where we want to assess and freeze the design to be able to release a small captive fleet for something like 20 to 50 sets of vehicles. And the target is really to have real retrofitted vehicles.
Very good. So one point, if you want to see the van and want to book an experience with us, you come to H4. That's where the stand is. So it's easy. H2, that's what we discussed about. Our stand is H4. Come and book a timing with us, and you can come in the van, and we will drive you around here, and you will see this solution is amazing. But maybe a final word on the next slide there.
Yeah,
which is other opportunities for sure for it.
So after we are often asked, okay, we made a utility van, but what are the different applications of H2-ICE where it does make sense? So the early development, it was a lot of requests from heavy duty business, off-road business, And now we see that basically anybody that was designing ICE engine is asking us to provide the solution to test and assess this on the vehicle. So here you have a batch of different engines and applications. So it goes from light-duty vehicles, it goes for heavy-duty, gensets, off-road machines, and even motorsport. They all want to assess, okay, if I convert my actual engine to an ICE engine, what are the results? So on the booth close to us, you have even one heavy-duty engine, which is also an ICE engine. So more and more, you will hear about this ICE technology. So the next slide, basically, with the van, we start to make really open road tests, like long trips. So unfortunately, in France, there is not that much station, so we always have to find the proper way to refill. But we are starting to make more and more long trips. So the idea, we are driving in Rotterdam in the road. By the evening, we will go and refill at the Rotterdam station from Air Liquide. And it's really a normal car for us to use.
And here it is. Good, thank you very much. That's, again, meet us on H04, H4, H2 is the same stuff, so please, you're more than welcome. Yes, thank you.